So in the previous video, we saw how to expand different binomials using Pascal's triangle. Here is an alternative method. But before we get to the binomial theorem, let me just first introduce the binomial coefficient. And for those that are going to take statistics, it's going to be useful because you do a little bit of this. So what the binomial coefficient is a new notation that it kind of looks like division, has parentheses, and it has n and r. And the way that you say this is n choose r. So I have n items, and I'm choosing r at a time. So we can write n taken r at a time. So one thing that you can probably think about is, like, let's say I have 4 different stars, and how many ways can I choose 3 stars from the 4? Well, I can choose to take these 3. I can also choose to take these 3. I can take the first, the last, and the second to last. So there's many different combinations that I'm looking for. And this binomial coefficient will help me figure out how to figure out that combination. So the definition of n choose r is equal to n factorial over r factorial n minus r factorial. So let me just do some questions on this. So let's say we just want to evaluate this. Okay, so evaluate 5, choose 1. So in this case, n is equal to 5 and r is equal to 1. So let's put this in in our formula. N factorial over r factorial n minus r factorial. N in this case is 5. That's 5 factorial divided by 1 factorial. 5 minus 1 factorial. So I'm going to have 5 factorial divided by 1 factorial is just 1. 5 minus 1 is going to give me 4 factorial. So one thing that you can do, a little shortcut, instead of multiplying everything out, 5 factorial is just 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. Notice that the 4, 3, 2, 1 cancels out with the 4, 3, 2, 1. And what I'm left with is just 5. So basically what this means is that, let's say you have 5 items, and you're only choosing one of them. This 5 means that there's 5 different ways in which I can choose from 5 items. I'm only choosing 1. So here's one way, 1. Here's another way. I can choose this one, I can choose this one, and I can choose this one. So there's 5 different ways. So it kind of makes sense, okay? But some problems can be a little bit more difficult. So let's try one more. Let's say we wanted to do 7, choose 3. So in this case, my n is going to be 7, and my r is going to be 3. So this is going to be equal to n factorial over r factorial n minus r factorial. So this is going to be 7 factorial divided by 3 factorial, 7 minus 3 factorial. The top part is going to be 7 times 6 times 5 times 4 times 3 times 2 times 1. Here I'm going to have 3. So that's going to be 3 times 2 times 1. 4 minus 3 is going to give me, 7 minus 3 is going to give me 4. 4 factorial is going to be 4 times 3 times 2 times 1. Okay, so I have this part, which is a 3 factorial. This part is the 4 factorial. Top part is just a 7 factorial. Notice that the 4, 3, 2, 1 go away. So I'm left with the top part, which is just going to be 7 times 6 times 5. That's going to give me 210. Divided by 3 times 2, which is going to give me 6. So 210 divided by 6 is going to give me 35. So what this really means is that if I had 7 items, 1, 2, 3, 4, 5, 6, 7. I had 7 different items. The number of combinations that I can choose 3 from this 7 is 35 ways. So I can choose these 3, I can choose these 3, I can choose these 3, and then I can do other different ways, and there's 35 different ways. Now, why is this important? Well, this is basically what the binomial theorem says. So an additional way, so let's say you didn't want to use Pascal's triangle, which I don't know why you wouldn't, but let's say you wanted to use something else. Well, there's a binomial theorem. So the binomial theorem says that if I want to expand a plus b to the power of n, then I can use the following formula. N choose 0, a to the power of n, plus n choose 1, a n minus 1 to the b to the 1, plus n choose 2, a to the n minus 2, beta squared, plus all the way into n choose r, a to the n minus r, b to the r, plus all the way to the last term, n choose n, b to the n. Now this looks really scary. This is what we call the binomial theorem. It looks really scary. It actually isn't bad if you know what the formula is. The only thing is that notice that the a's do end up dropping, just like how we said before. That the a's start off with n and then they go down by 1. The b's go up by 1 each time until you get to the last term. Now the thing is, like, if you forget Pascal's triangle, you can do another method. You can just start off with n choose 0, n choose 1, n choose 2, n choose all the way until you get to the last one. And that will also still give you the number. So in case you forgot what Pascal's triangle is. And I'll show you how to do it. I'll give an example, one quick example. So let's use the binomial theorem. Okay, so let's say we had p plus q raised to the power of 4. Now you could easily use the Pascal's triangle. You won't get docked points, but for this problem, I'll just show you the binomial theorem. And if you like it, you can use it. If you don't like it, then it's okay. You can just use Pascal's triangle, but it's just an alternative way. So we first want to go ahead and do this. So p plus q to the power of 4. Well, the first thing that it says is that I'm going to have n choose 0. n in this case is equal to 4. n equals 4. Okay. So I'm going to start off with 4 choose 0. And then I'm going to have p to the 4th, because I know that the first term is going to have a 4th power. Then I'm going to have 4 choose 1. P to the 3rd, and then I'm going to have a q. Then I'm going to have 4 choose 2, p squared, q squared. 4 choose 3, p q to the 3rd power, plus 4 choose 4, q to the 4th. Okay, so notice here, the coefficients are just 4, which is going to be this power. You start at 0 all the way until you get to 4. The p's, they start at 4, and then they drop by 1. The q's, they start at 0, and then they go by 1. Okay? Now the thing is, here we have to use the formula. So when we put this in the formula, here I'm going to get 1, p to the 4th power. When I put this in the formula, I'm going to get 4, p cubed, q. When I put this in the formula, well, you can put it 4 factorial over 2 factorial times 2 factorial. P squared q squared. This one's going to be 4 factorial over 3 factorial. 4 minus 3 factorial. P q cubed. And this is actually just going to give me 1 q to the 4th power. So the only drawback is that you do need to calculate these things. So this is going to be p to the 4th power plus 4p cubed q plus 6p squared q squared plus 4p q to the 3rd power plus q to the 4th. So notice it might have been easier to just use Pascal's triangle, because it'll be easy to know that this is just going to be 1, 4, 6, 4, 1, which if we go back up was actually this row, 1, 4, 6, 4, 1, which is row for power 4. So you do have an option. You don't need to use this formula if you don't want to. If you really are not digging this one, you don't need to, but this is just another way in which you can expand a binomial.